All right, so the notes over 5-4 and 5-5 for equivalent fractions are really similar to ratios and proportional ratios. And if you look at the directions, it says write a ratio, so it's even using the same vocabulary. But it says write a ratio that represents the shaded portion to the total shown for the first four. So if you look at the water bottles, there's 4 that are shaded blue, and then there's 10 total. So your fraction would be 4 over 10. And then if you look at that, you could see they're both even numbers, and so you can simplify that. So 4 over 10 would reduce to 2/5. You just divide both numbers by 2. Number 8, there's one piece shaded out of 1, 2, 3, 4, 5. You can't simplify that, so it's just 1/5. And then this one's really hard because the lines are really tiny. But if you count all of the little tick marks between right here and right here, there's 10. And then there's, let's see, 1, 2, 3, 4 shaded. So again, it would be 4/10, which is the exact same answer as number 7. And then when you reduce it, it goes to 2/5. So these two are the same. And then try number 10 on your own. Count the shaded dots, and then count the total number of dots. And then if you can simplify it, do so. You should have gotten 5/16, which cannot be simplified. Number 11, you need to count the total number of tick marks. So let's see, there's 1, 2, 3, 4, 5, 6, 7. So between 0 and 1, there's 7 little tick marks, not including 0. You start with 1 being right here. So we've got 1, 2, 3. This would be 3 out of 7. And then we've got 4, 5, 6. This would be 6 out of 7. Try number 12. 1, 2. All right, so you should have counted 5 tick marks between the 0 and the 1. And then this dot was on the second one, and this dot's all the way over on the fourth. So 2 out of 5 and 4 out of 5. And then drawing a number line to represent, I'm just going to show you the completed notes. Sorry. Okay. So on the bottom, it says draw a number line to represent 7/12. So you have to first draw a number line that has 12 little tick marks in it, which if you look at my number line, I made it too big, and so I quit making the little dots. But that's fine if yours looks like mine. My second one I did a little bit better. But there's 12 little tick marks, and then you just put a dot on the 7th one. And then this one, it says 5/8, so you would draw a number line with 8 tick marks, and then the dot would go on the 5th one. Oops. So go ahead and copy those number lines down while I erase. All right, the last two say to draw a set and to draw a region. A set just means you're using pictures, so I use dots because that's the easiest thing to draw. So it says 2/3. So just like on the top, they drew pictures to represent 1/5, 2/5. You can draw whatever you want. I just drew dots. So I drew 3 dots, and then I shaded 2 of them. So this would be 2/3. And then a region just means that you're drawing like basically these little sets of squares. So you draw a big rectangle, and then you break it apart into 9 squares. So if you were to count, there's 9 little squares in here. And then I shaded 6 of them because it says 6/9. Your pictures don't have to be pretty. Okay, The bottom half, these are a long set of notes. It says write two fractions that are equivalent to the given fraction. So this is the same thing as proportional ratios. So I'm just going to go ahead and flip to this screen. You do need to have this copy down, but this was when we'd have to multiply or divide the numerator and denominator by the same number. So if you look here, I've got 3/8, and then I multiplied 3 by 2 to get 6, and then 8 by 2 to get 16. I could have done whatever I wanted with multiplying by whatever number I mean. I just chose 2 and 3, which is the same thing I did when we did proportional ratios. But then 3 times 3 is 9, and 8 times 3 is 24. So let's go back. So 12 over 21, you could look at that and see that 3 goes into both of those numbers. So if you wanted to divide, 12 divided by 3 is 4, and then 21 divided by 3 is 7. So 4/7 would work. And then I want you to try to think of another one. If you need to pause the video at any time, go ahead. And then we've got, because it says to come up with 2, so you need to have 2 written down for each one. But then on number 12, you've got 8 over 32. And both of those can be divided by the number 4. So if you divided by 4, you would get 2 over 8. And that can actually be reduced more. So you could divide by 2 again, and you can get 1/4. So I already gave you the 2 examples for that. So go ahead and this should not be new. Go ahead and pause the video and try to do 10 through 17 on your own. Remember, if you don't want to divide, you can always multiply by 2 and 3 or by 10. Multiplying by 10 is always pretty easy. Go ahead and do 10 through 17 on your own. All right, so if you didn't pause the video, then go back and pause it so you can finish that. But these are sample answers, so you might not have multiplied or divided by the same set of numbers as I did. So you might just want to check your own math, but these are sample answers that you could have had down for 10 through 17. Oops. Okay, it says how can you use equivalent fractions to know that 43 over 200 is between 1/5 and 1/4? This one's a little tricky, but if you were to put 1/5, and I don't know if you guys remember this, but you have to change it to like the magic number, or I guess in this case it's 200. But so if I were to get 500, or 5, sorry, I keep messing up. If I were to get 5 to be 200, I would have to multiply it by something. So for 5 to be 200, I have to multiply by a very large number. Let's see. All right, 40. So to get 5 to be 200, you have to multiply by 40, which means you have to multiply 1 by 40, which is just 40. And that's taking care of the 1/5. Now we've got 1/4. Let's see. So we need to get 1/4 to be an equivalent fraction with 200 on the denominator. And 4 times 50 would get you to 200. So 4 multiplied by 50 is 200. So 1 multiplied by 50 is 50. All right, so now if you look back over here, it says, how can you use equivalent fractions? So by doing what we've just done, we've made equivalent fractions. And then we've got 43 over 200. Is 43 over 200 equivalent to 40, or in between 40 and 50? So basically all you have to look at now is, does the number 43 fall between 40 and 50? And the answer is yes. Okay, go ahead and make sure you have the rest of this copied down. On A and B on the bottom, you needed to use cross multiplying. So 5